Sound okay? Whoa, that's loud. Yeah, good? All right. So happy to be able to play a little bit of music for you, play a little bit of command line interface for you. We at NuCypher, we develop what we think are interesting and novel cryptographic primitives and the cryptological narratives and logic to go with it. Today we're going to be talking about our proxy re-encryption project. And the sort of root of that is rethinking this 40-year-old idea that all cryptographic conversations take place between two parties, Alice and Bob. You all know Alice and Bob. Alice sends a message and Bob receives it, and there's a number of different ways that it can work, but typically Alice encrypts something with Bob's public key, and then only Bob can decrypt it. In a decentralized narrative, it's totally plausible that you might want to break these characters apart, but it's difficult to do. One thing that we've done is introduce this other guy, Enrico. So now we have Alice, Enrico, and Bob. You're used to thinking of Alice as the authority, meaning she decides who gets the message, but also the messenger, meaning she decides what the message is. In our narrative, Alice is still the authority, but Enrico is the sender of the message, the encryptor. Alice the authority, Enrico the encryptor. We introduce also another character who we call Ursula. So this is a total of 4 characters, and I'll give you a little preview here. We're going to do like a Brady Bunch thing here in my CLI, all right? We got 4 characters. So Alice creates a policy and on Ursula. Ursula are our nodes on the NuCypher network. She grants access to Bob. Now, Enrico can encrypt a message, not for Bob's public key, but for the policy public key. Then Bob goes to Ursula and she can re-encrypt it. That is to say, she can change the ciphertext from being encrypted for the policy public key to being encrypted for Bob's public key without ever seeing the clear text herself. That's the basis of this whole system. Now normally, when we do these demos, we've demoed our testnet, we've shown long scripts that have all 4 characters going back and forth, but we figured, hey, this is a hackathon. Let's get deep into the internals. So I am going to try to operate 4 different tiles in a CLI and show some things that are really bleeding edge, some things that we were hacking on in preparation to hack here. We take this very seriously. I think there's sort of in the blockchain community an equivalent of impersonator syndrome, where you think to yourself, oh, nobody's really going to use this project. No, people are going to use this project. We feel confident about that, and we feel confident about a lot of the other projects out here. Confident enough that we are willing to dig into things even that are broken to kind of show you the insides. Now, if you'd rather see a demo from a script that shows how our testnet, which again is launched and working, if you want to see how that works, watch my talk from Prague or Berlin. All of those are on the NuCypher YouTube channel, all right? But right now, I'm going to go into some stuff that is just thoroughly new and broken, and I'd love for you to explore with me, and I'm going to play a little bit of music and a little bit of CLI. Here we go. So the first thing we do is we're going to launch Ursula. I don't know, I feel like I'm real hot on this mic. Our NuCypher command line tool has character names for each of the 4 characters. Okay, so what I'm trying to show here, actually I'm going to do Ursula down in the lower right corner. What I'm trying to show here is that you can launch, once you install NuCypher, you can launch each of the 4 characters here yourself. So what I'm going to do first is NuCypher Ursula run. I'm going to do this in dev mode, meaning I don't want to persist. Just want to run once, and when I Control-C, it's all over. Federated only, I think that's all I need. All right, and we get Ursula. Okay, so here's the first of the 4 NuCypher characters running in one terminal. Next, we are going to run an Alice. So we're going to start with those 2. Now remember, Alice is the authority of the policy. Ursula is the node I just described that does this re-encryption. Okay, so I'm going to come over here and do basically the same thing. NuCypher, Alice, going to do -- help. We do have nice help screens for each of our characters to sort of help you understand how to use each of them. NuCypher, Alice run, also dev, also federated only. And I do want to make a note here. When I say federated only, what I mean is that this is not using the economic dynamics of the blockchain. Right? Normally, in order for Ursula to perform this re-encryption, Ursula needs to stake our work token, and our entire node discovery is based on, and sampling is based on that stake. Okay, I'll talk to you more about the security implications of that in a little bit. But I am going to pass our teacher URI, which is that Ursula that I'm already running. Okay, and you can see down here that it's running on port 10151. So that's what I'll type here. Alice is running. Alice has learned about this Ursula. Awesome. Now the kind of crazy part. Okay, I am going to open up IPython, if I even have it installed. I do. I'm going to set up some import. One thing I want to be really clear about from the beginning. Inside this IPython, NuCypher is not defined. So this might be your Python application that maybe you're writing. We like Python. I think it's a great idea to be writing blockchain apps in Python right now. Wonderful effort and enthusiasm in the space. But even if you're writing in Rust or JavaScript or whatever you happen to be writing in, what I'm doing here is just making HTTP requests in this middle window. So this is what you can do with your app if you don't want to import NuCypher as a library. And again, when I've just showed you, I get name error for NuCypher. So I'm not leaning on the NuCypher library inside this middle one. And we're going to see how far we can go before things break. I know I'm going to need, we do some base 64 encoding, so I'm just going to take care of importing the base 64 stuff right at the beginning. We also use JSON. Okay, and then I'm going to be, the main tool I'm going to be using is requests. If you're not used to Python, requests is sort of the main HTTP tool that most people use just to make requests and receive responses. So the first thing I'm going to do here is let's go up to the top of Alice, and I'm going to jot down Alice's address. Okay, she's running, again, on localhost on port 8151. I need HTTP there. Nope, that's not right. And I'm also going to grab Alice's verifying key. Sorry about that. Okay, now I'm going to make the first HTTP request in the system. I'm going to derive the policy key. Now remember, the policy key is what everybody encrypts for. Nobody's encrypting for Bob's public key in the NuCypher cryptology. Instead, you might imagine that Enrico is like on the countryside in a war-torn situation. He pulls out of his pocket, scrawled, this one single encrypting key that he managed to keep a hold of. As long as he can encrypt for that, all the Bobs that are in the policy, and Alice decides who those are, all the Bobs in the policy can read it as long as Enrico encrypts with this one key, this one public key. So let's make that. Here's my derivation. We'll say derivation response because I'm going to make this request. And this is to Alice / derive policy pub key, and we are going to call this songs. I think that looks right. Let's see. Derivation response. Good. Okay, now look, here's the policy encrypting pub key. Right? So that didn't exist before that request response cycle. Okay? It is a key pair. Alice has the private key, and only the person with the private key can grant and revoke access on this policy. So the next thing I'm going to do is just in my Python state here, I'll save that. This is going to be the policy encrypting key, the one that we just got. And now it is time to run Enrico. So here I'm going to do essentially the same thing. I'll do NuCypher Enrico -- help. Okay, here we get the help options for Enrico. I'm going to do NuCypher Enrico run --. By the way, I'm looking at the help text right along with you all. I'm like really, this is going to be the first time I've gone all the way through this. I've done some trial runs, but I mean, this is literally a day old what I'm showing you here. This is what we are hacking on now. Policy encrypting -key, and I pass this, and this I think will launch Enrico. There we go. Let me zoom in on that a little bit. Oh, not that much. Okay, so now you can see sort of the beginning of this thing coming together, right? I've got 3 terminal windows, 3 different characters. You yourself can do the same thing if you want to develop with NuCypher. Okay, now the next thing I'm going to do is I'm going to copy Enrico's port, and I'm going to come back over to my Python here that I'm working on, and I'm going to say Enrico is http:// again localhost. This is all running locally, and Enrico's port. I also need to grab Enrico's verifying key. Okay, this is the key that when Bob gets a message, maybe in your narrative, Enrico is someone important, and Bob needs to know that this came from the person he's expecting. Maybe not. Either way, you want to grab this key and validate the signature. Maybe the signature is meaningful to you in the sense that it's coming from a trusted party, but either way, you want to validate. Okay, now we're going to pick a message to encrypt. I figure the label is called song, so we'll pick the next song that we're going to play together. I got a request from Nuke Man Dan, I don't know if he's in the room, but to play, zoom in on this a little, from The Legend of Zelda, the Ocarina of Time, we're going to play Lost Woods. All right, so there's our message to encrypt. Yeah, that's supposed to be bytes, thank you. I've got a little, half my colleagues are in the front here yelling out to me all the things that I'm doing wrong, and it's going to get worse. So now I'm going to make the encryption request. This is where stuff starts to get a little crazy, but this is really just this is a JSON dict where the key is message, and I'm going to encode it to base 64. Again, it's already bytes. The only weird part, and this is arguably the strangest part of this whole presentation, is that I then have to decode it to UTF-8 to send it over the wire. Don't concern yourself with that for the moment, or if you're used to operating with internals of these sorts of APIs, maybe you're already used to it. But and now I'm going to I'm going to see if I can get the encryption response. Okay, so now I'm going to post to Enrico. If there are any Python fans in the audience, look at me. I'm using F strings here, I'm really hip with the cool kids, right? And I'm going to hit his encrypt message endpoint. And here I'm passing data, and I'm going to do JSON dumps for the encryption request. That one. Okay, let's see here. Encryption response. .content. Look at that. Now we've got what we call a message kit. Okay, that is a message that is encrypted for the policy public key, not for Bob. Okay, and we'll show that now because we're going to launch Bob. We're going to do NuCypher, same thing. I'll do Bob -- help. NuCypher, Bob, run, very, very similar. Again, we're federated only here. Bob's not concerning himself with the token right now. And we're going to do teacher URI, which is going to be the same as Alice was. Okay, when you all hack, you feel free to use our testnet right here, right? But I'm trying to show this 2x2 screen. There we go. Now we've got all four characters, all 4 main characters. We actually have several other really wacky characters that I'd love to do a deep dive through the secondary characters of NuCypher at some point, but now we've got all right, that's all we're doing to that. No more, I'm not big on the Kitsch America memes, but when you do Brady Bunch, you do the Brady Bunch, right? Okay, now we're back here. And we're going to try to retrieve. Right? Now, in a traditional public key cryptography scheme, this operation, I didn't say Bob yet, actually. Let me do that first. I've got to do Bob. Bob is going to be http://localhost on port 11. 11151. I don't know who comes up with these port numbers. That's not true. I do. And now we're going to do Bob's verifying key. Whoops, in here. All right, cool. Wrong key? Oh, that's Enrico. Yeah, all right. Bob's verifying key. Oh, yeah, we need both of Bob's keys. Bob's verifying key. They're trying to leave me with as few excuses for this failure as possible. Okay. Now let's make a retrieval request. Let's see what happens when we try to retrieve this data. Remember the name of the song. Okay, for that, we need the same label that we used at the beginning. Let's just start a dict here. We need the same label that we had at the beginning, which is just the word songs. We need the policy encrypting pub key, okay, which we saved here as policy encrypting pub key, I think. Good. We also need Alice's signing key, or verifying pub key. Alice verifying key. And then finally, we need the message kit. Let me go get that message kit. It was the encryption response. So we'll do the message kit is, remember, encryption response .content. Okay, but we need to JSON load that. And we look up result. And from there, we look up message kit. Let's see what that comes out to be. That's correct. Okay. And so for our retrieval request, our message kit is that. Okay. Now let's try to retrieve. So I'll do request.post. Okay, to Bob. We're going to hit his retrieve endpoint and say, hey, Bob, go ahead and try to retrieve json.dumps, that retrieval dictionary that we just put together. Oh. Okay, I believe we will get a 500 here. And we do. Not the prettiest access denied message. We'll work on it. If you need something better, we'll make it for you. Come up to our table on the second floor here, right at the top of the stairs. So now what we have to do is grant access to Bob. What has happened so far? Enrico encrypted for the policy. Bob tried to retrieve, but Bob can't retrieve because he's not on the policy. Okay? So now the next thing we're going to do is make our grant. Okay, in granting access, we need Bob's signing key. We need Bob's encrypting key. Okay, so if you're Alice and you want to grant to Bob, first you got to find a little bit out about the dude. All right, gather this little bit of information. Here I'm just going to do M and N values of 1. If you already are hip to what that stuff means, that's cool. But if not, definitely watch some of our other demos where we go deep into that. And I'm going to do label. The same one, of course, is just the word songs. Okay, so now we're going to I'm going to do requests dot put, this time to Alice. And we're going to say, Alice, grant access to Bob. Grant. The data here is going to be json.dumps for that grant. What? Oh, yeah. Going to need that. Okay, /grant. There we go. There's a 200. The grant ostensibly went okay. Okay, now, let's see here. We're going to try to retrieve again. Okay, I'm going to put the same exact thing I put when Bob last tried to retrieve but failed. We're not going to change anything. Retrieve, and the data is json.dumps for our retrieval. Does that look good? Where? Yeah. There. How's that look? Everybody like that one? Okay. Retrieved. Let's see. It's a 200. Let's see what the content is. Okay, he's got some plain text. Hold on. We're gonna do retrieved in base 64. This is gonna be, we're gonna load that response, okay, retrieved. You ever have that thing where you see a word so much it starts to look weird? I'm having that with retrieved right now. Retrieved.content, result, and we're gonna take that plain text. Well, I messed something up there. What did I do? Let's try that one more time. I had mismatched. Yeah, okay. Just bear with me. Loads. Retrieve.content. That's what's being loaded. We want to get the result, and from the result, we want the plain text. This thing. That. Okay, now we are going to B64 decode that. Actually, we need the first member of that. It's possible that Bob has received many messages. In this case, he only received one, but we take the first one, and look at that. We get... I cannot believe that worked. I did not expect that to work. All right, so what just happened? Enrico encrypted that message, not for Bob, but for the policy. Bob tried to get it. He wasn't granted on the policy, so he was unable to get it. Then Alice granted him. Then he was able to get it. You can do this in your hackathon projects. It's totally decentralized. Again, Ursula, in the real world, you'll use higher M of N values. Using 1 and 1 is totally insecure. In the real world, watch some of our other demos, and you'll understand how that works. Paying for higher values will cost you a little bit more, but our nodes, our Ursulas, will do that re-encryption service for you. And now you can grant access via, in a totally decentralized fashion. Now I think that I owe you all a song, so. All right, and now, a little bit of guitar and questions, if anyone has questions. What do we have, 6 minutes? 6 minutes for questions. Who's got them? Yeah, I think, I don't know if you need to come to the mic. If not, if you want to yell, I'll repeat your question. Little sound in this mic. What?
Hi. Does Bob ever find out it came from Enrico, or it just knows it came from the policy?
Bob does get, ideally, Enrico's verifying key. You want to check that to make sure that there was no funny business with the ciphertext in the first place. Now, you can use, and we do use in our demos, a different Enrico for every message. That's no problem. So Enrico doesn't need to have personhood in the sense that he persists across the network, tying any sort of identity to his key. But you want to at least check that signature. So the answer is no unless you want to.
Got it. Thank you.
Other questions? Can you all hear my guitar? Is it coming through? Come on, other questions. What's going on? I'm happy to sing for you for just a little bit. Well, it's been a pleasure to share my CLI with you. I really look forward to seeing the other presentations here. It's really fun to be part of something so awesome. In NuCypher, I think we've really, I don't mean to boast, but I feel like we've built a really elite team of good friends building some wonderful things, and I know a lot of you have also. We're interested in using your stuff, and we're interested in you using our stuff, and this is a great place to make that exchange. It's also been really fun sharing my CLI with you. It's been a long time since I've done just straight up absolutely live coding like that. I'm really, it's awesome that it worked. It came together at the last minute. It'll work for you also, and of course it'll only get more solid. We built that this morning, so there will be lots of upgrades and support to come. Thank you so much.